We're going to talk about vectors today. The whole unit in kinematics and vectors are, although separate, they really are nothing more than an opportunity for us to have a common set of vocabulary and basically a toolbox to be able to communicate. The first real unit in physics is Newton's laws, which we don't get to for a while because we're so busy making sure you can read graphs and do stuff like that, which is just so arbitrary generally. So what we want to do right now is talk a little bit about how we communicate to each other information about vectors. And this, I always like to say that this is review, but I always find that there's such holes in your understanding that it's never review. But we'll try. If you're in pre-calc last year, it is very plausible that you learned a ton of bad habits. And it's not to the detriment of your teacher. They were just teaching you what they were required to do. Unfortunately for us, that leaves a huge, huge cavity in what you need to be able to understand. So if I were to say that let's say that this vector represents the velocity of the wind, and it's 30 kilometers an hour, and the angle I have is 30 degrees. One of the biggest problems that pre-calc has is they have standards that they work with. And this is all math, but they have standards that they work with that don't really allow for a lot of flexibility once you leave their math class. I mean, they have decided that this is 0 degrees, and you will measure angles from 0 degrees in a counterclockwise fashion. That way, x is always r cosine theta, and y is always r sine theta, and you can then deal with negatives and positives and determine the angle and vice versa and all that garbage. Sound familiar from the unit circle work? The real problem is that the unit circle then does not translate to real life, where we tend to put north at the top of our maps. And north is 0 degrees, and we go clockwise. Now, none of these are right or wrong. They just all have different points of reference. So I could tell you that the wind is 30 kilometers an hour at a whole angle of 60 degrees. If I say it like that, then the implication is that I am using the positive horizontal axis as 0, and I'm measuring the angle off at a raw 60 degrees from that vantage point. But that is terribly inflexible and terribly ambiguous. So instead, we tend to establish what is 0 and then state our angle by giving direction from 0. So in this case, I would say, because we're talking about the wind, and because it's the wind and we tend to deal with our map, our real environment, I would say that this is 30 degrees east of north. What I'm doing is I'm establishing 0, north, and telling you how many degrees to turn and in what direction. So face north, turn towards the east, 30 degrees. This method of establishing a vector gives us what 0 is, tells us what direction is positive, and then establishes our angle based on that. So we are not going to callously assume that all angles are given based on the same reference. For all of you who have been in physics once before, you know we're eventually going to get into things like force diagrams. And force diagrams aren't going to have x be the reference point. We're going to choose our reference point based on what's most useful to our problem. So we have to break away from that unit circle, that fixture that you had last year. Because this could also be 30 kilometers an hour, 60 degrees north of east. it means the same thing. Now, I'm going to stop for just a minute, and I would like you guys to take over and tell me what the components are. You should be able to figure out two sets of components. I don't care how you do it, but in a few minutes, I'm going to ask for a horizontal component and a vertical component. I'm going to choose two different people. So take a minute, break out your trig, and I'll let that fly for a second. I'll give you 2 minutes.
The x component is 15 kilometers per hour.
Okay, the x component, well, I'm just going to put the horizontal component, is 15 kilometers per hour. And let's play wheel of participant here. Davon, can you give me the vertical component?
That's 25.98.
All right, so I'm going to just do 26 kilometers per hour. So we now have the two components. And you guys have learned, I think, 2 or 3 different ways to write rectangular components. The first one you probably learned were ordered pairs, right? We're talking elementary school. This vector can be described by an ordered pair. I know that you always thought of that as a coordinate, but that is actually an efficient way of writing a vector, the two numbers, and it's assumed that this is the x column and this is the y column. Does that seem familiar to you all? So we're not going to do it like that. Our expectation is that you go a little bit further. We're going to use IJK notation or XYZ notation, which means we write a rectangular vector as a mathematical statement. So these two things could also be written as 15 I hat plus 26 j hat. And I know that you guys have had to figure out, well, Max hasn't because he didn't learn, but how to figure out how to put the little I hat on there by using the little thingy. Sorry, Max. But a whole argument ensued in E&M, so I have to exploit it here. But he also pointed out that you could just do I / and type the word hat. And apparently, Mastering knows what that means. But this is one way to write it. This is a vector statement. Another way, of course, to write it would be to actually write it as 15 x hat plus 26 y hat. This is kind of the way I used to do it when I was in high school. Well, no, I never learned this in high school. When I was in college. But the more predominant method is IJK notation, which doesn't make any sense to me why they would have to have IJK when XYZ is already out there. But it doesn't matter. That's the way we do it. Now, I'm bringing this up not because I think you guys are inept or don't know this, but because if I don't say something like this at the beginning of one of these discussions, there's always 1 or 2 students who have forgotten small pieces of this or never learned it and don't speak out about it. And therefore, they get lost when I go to the next step. Because this isn't what I want you to know. What I need you to be able to do is to add vectors together. And to add vectors together, you have to understand that we don't have a set of tools that allows us to directly add vectors together. You might not believe this, but your calculator will do all this for you. Except it won't add vectors together. It will convert vectors from one side to another, but they won't add vectors together. In the great calculator wars, HP used to be a big contender. In fact, there were no Texas Instrument calculators when I went to college. Everybody used HP. And we've always pooped on Casio. So if you have a Casio, yeah, no one likes those. Nobody ever liked Casio. Who's got a Casio? It's always somebody. Yeah, nobody's going to raise their hand now, but HP calculators could manipulate polar vectors naturally without having to convert to rectangular. It was awesome because it could do all of that matrix manipulation right there in the calculator. Nowadays, that's been lost. So the only method you have available to you is to do it by hand. And if you don't yet understand what I'm talking about, what if I told you that the wind was blowing at 30 kilometers an hour, like so, but an airplane was flying at 100 kilometers an hour due west. I have to draw it over here so I can pick it up and move it. Oh, it's in the way. Come on, just move. Be my friend. What if I now want the actual velocity of the plane? This is called relative velocity calculations. And every pilot has to learn how to do this manually, or at least they used to. Now, Max, you're a pilot. Do you have the little calculator with the little spinny thing on it, and you draw the vectors on it? Yeah. I used to have a whole class set of those for fun. You need to be able to do this both graphically and numerically. And so I'm going to make two assumptions. One of them is that I can explain graphically and you could perform it when asked. We tend to not do it very much. It's mostly used just to give us an idea of the answer. But if you actually have a compass and a ruler, graphical calculations can be almost as good as just doing the actual math with trig. So don't throw those away. They're often much easier to do. But when you add relative vectors together, you add the vectors tip to tail, just like you're seeing here. I put them, it doesn't matter which order you put them either, but you add them tip to tail. Vector addition is like algebraic addition. The order doesn't matter, the result will be the same. But when you add them, the result is a vector that is drawn from the origin to the end of the final vector. So the red arrow actually depicts the flight plan of the plane relative to the ground. So the plane thinks it's going west because that's the direction it's heading, but the wind is pushing it off course. And because of that, the plane's actual velocity relative to the ground is the red line. To calculate it, you could do it this way. Make up a scale that represents the size of those vectors, draw them to scale, make sure the angle is accurate, and then carefully measure the angle and length of your resultant vector. Of course, I didn't do any of those things. I just drew them. There's no attention paid to scale, which is why we're going to have to learn to calculate it. And I will provide you a method, but some of you who's already done this before? 2 of you. So apparently we need to talk about this. Here is the method. You can't add vectors together unless they are in the same component direction, meaning you can only add things on a number line. So we have 3 steps. Step 1, convert to rectangular. Step 2, add like components. Step 3, convert to polar. The n should always be an answer given as a magnitude and an angle. So I tend to show students how to do this by drawing out a little kind of rubric where I have the polar and then the rectangular, and then the box at the bottom is the answer. converted back to this box, which is the polar answer. And that, my friends, seems to be the end of 6th period. So we did not finish. We will have to finish on Monday.